Well, hello, pre-calculus. Today, we're going to conclude our intro to calculus notation by looking at constructing graphs. So what's going to happen here is we're going to reverse roles rather than me giving you the graph and you giving me the description using whatever type of notation. I'm going to give you the description, and you're going to use those descriptions to create the graphs. So our learning target basically says the same what I just said. You will be able to accurately construct a graph using a description, which is composed of one or all of the following: intervals, extrema, and limits. Extrema is the single word that encompasses both maximum points and minimum points of absolute or local, just all wrapped up into one word. So when we are constructing a graph, there's different types of information which is presented to us, and we need to put it onto the graph in a certain order in order to avoid complications and errors. So first, any type of point. If you're given the coordinates of a point, put those on the graph first, because those are fixed locations that we absolutely know the graph goes right here. So that could be a maximum point if you're given coordinates of it, minimum point, again, if you're given coordinates. It would not include like an absolute maximum that's infinite, because I don't know exactly where to put infinity. Anything with set coordinates. It could be a point we're given using function notation, like a lot of times with limit notation. You got the left-hand limit, the right-hand limit, the two-sided limit, and then there's that extra point where you say, what is the function value? If that is given to us, those function values create coordinates, and not written with as coordinates, but they give us the coordinates of a point. So put that on the graph. And sometimes we're given intercepts, x-intercepts, y-intercepts. If you're given any of those, put those on the graph as dots. Secondly, we're going to use the limits next. So with limits, sometimes we have open dots and sometimes we have closed dots. I'm going to suggest that you always draw these onto the graph with open dots to begin with. Later on, as we find out additional information, if it turns out we need to fill in that dot, it's really easy to fill it in. It's slightly harder to erase a dot and redraw it as an open dot. So just start with open dots, fill it in if you need to. Lastly, intervals. So basically, we've got points, whether they're closed dots or open dots, from the numbers 1 and number 2, and we use intervals to connect the dots to fill in all the gaps. So intervals come last in this process. Let's take a look at an example. Here's number 1. So the directions ask us to use the following information to sketch a graph of the function on the provided grid, which is below. Start by plotting any points you know, then draw the curve itself. When we get to the part where we're drawing the curve, the number line is a useful tool. And I circled that in red because that really, what I mean by that, it has to do with our use of interval notation. Okay, so I've already looked through here. I took stock of what information we have. So over here in the upper left, all of these are intervals. So I know I'm going to use those third. So I've identified, yeah, I have some intervals. Don't use those first. Over here in the upper right, I have some coordinates. A few of these max and min points are infinite, so I'm not going to be able to put those on right away. But I've got some max points, min points, intercepts. Those are all dots on the graph. So I'm going to do that first. Below that, circled in blue, I have some limits. Some left-hand limits, right-hand limits, two-sided limits, some end behavior limits. Everything circled in blue represents a limit, so I will do those things second. And then buried in between some of those limits are some function values, which I circled in green. Those are coordinates. Those are points. So the function value at -3 is 4. This is the x coordinate, -3. 4 is the y coordinate. So really, I've been given the coordinates of a point. So I'm going to group that with the coordinates. All right, so let's go through here, starting with the points I have been given. So I'm going to max at -2, 6. I like to label things so that later on when I'm connecting the dots, I remember, okay, this point is supposed to be maximum. When I draw the rest of the graph, this should look like a max. It'll be easy for me to identify what's what if I have some labels right on the graph. Minimum at 4, 1. Again, so the labels are not required. This is just a helpful tool that I use. The infinite max, absolute max at infinity, and an absolute minimum at -infinity, I can't draw yet. I don't know how to draw infinity. That's not a point, right? So the x-intercept, -5, the y-intercept at +3. I don't normally label intercepts. It's on the axis, so that it kind of is clear to me that this is going to be an intercept. And there's nothing special that when I'm drawing something about how you draw an intercept. It goes through that point. So then I've got some function values. I got two of those. So at -3 and 4. There are some coordinates in the other one. 1, -3. So I'll put both of those on here as well. -3, 4, and 1, -3. All right. Limits. I'm going to start with the left-hand column. All of these are at the same x value. So all three of those limits as x approaches -3. So I have a left-hand limit, I've got a right-hand limit, and I have a two-sided limit, but they're all at the same x value. So let's do the left-hand limit. I've got the little minus sign telling me I'm approaching from the negative side, so I know it's the left-hand limit. So x is -3, and the function value is approaching 1. So I'm going to draw this as an open circle, and I always put a little tail sticking off to the left-hand side so that when I am connecting the points, I remember, hey, that should connect to the part of the graph coming from the left. You can also label it, if you find this helpful, with a little LH for left hand or whatever you find helpful. The right-hand limit, x is approaching 3, and the y coordinate is 4. I already had a point there, so I would have drawn this as an open circle, except I already know that's a point because of the function value that I put on here first. So I'm still going to label this as a right-hand limit and put a little tail sticking off to the right. Okay, now I'm not limited to like I have to connect to the where I drew the little tail. I don't know that it should stick straight off to the side. This is just a reminder to myself that I should go to the right at that point. All right, so once I have the right hand and left hand limits drawn, next there is the two-sided limit here, which does not exist. And so really this is just confirming what I think was already I was already thinking this in my head. So if I have a right hand limit, which is in one place, and I got the left hand limit, which is in the other place, and they're not touching at the same height, probably I already knew that the two-sided limit doesn't exist. Right? Well, this is confirming it. So when I see that the two-sided limit at -3 as x approaches -3, that doesn't exist. I know for certain the graph is going to be discontinuous. On the one side, it comes in at one height. At the other side, it goes at another height. So there's going to be a gap in the graph. When I'm drawing it, I'm going to put my my pen drawing coming into the left-hand limit, pick up that pen or pencil, and then put it down at the right-hand limit and continue drawing from there. So I don't need to draw anything on my graph. If you find it helpful, you might make a note to yourself, like the right-hand limit and the left-hand limit should not connect to each other. If you need more reminders, then find a way to remind yourself. The other limits in the right-hand column all have to do with an x value of 1. So I've got a left-hand limit at 2 as x approaches 1 from the right-hand side. A right-hand limit also at a height of 2. And the two-sided limit also x approaches 1. The function has a height of 2. So all three of those are the same. So at an x value of 1, I'm going to go up to 2. I am still going to put this as a open circle because just because the graph is approaching that point, I don't know yet that it actually exists as a point. So I'll just label this as a two-sided limit, put a little tail on both sides so that when I start drawing, I remember that I should come into this point and also leave from that point. And oh yeah, way down here at the bottom, remember this green dot? I put it 1, -3. Well, now I know that is going to be a floating dot. It is not going to be attached to the rest of the graph in any way because the limit tells me where the curve is heading towards. So the curve, the line part of the graph is going to be connecting to what I just drew as the two-sided limit. This other point, that is where the graph actually exists, is not going to be attached. All right, and then down here at the bottom of the limit section, I have end behavior. So I've already labeled and circled some stuff in here. So the left end behavior, x is approaching -infinity. That tells me it's the left end. The function is going towards -infinity. So that'll mean down. I don't know how to draw an infinite thing, so I'm just going to make a note to myself over here in the margin. The left end behavior of the graph will be going down. So end behavior is described not from the perspective of a graph walker, but like if you're actually facing left. If you were somehow able to walk towards the left of the graph, you'd be going down. Interval notation, we would describe that as increasing because you'd start at the left and move to the right. But end behavior describes it from a different perspective. The right end behavior, as x is approaching positive infinity, the height goes up to positive infinity. So again, I'm going to make a little note in the margin at the right end. Graph will be going up. Okay, so now I have all of this limit stuff onto the graph. The function values are onto the graph, and then everything to the upper right, all those coordinates are labeled onto the graph. The only things that are not really drawn on the graph are the absolute maximum, which will be positive infinity, and the absolute minimum, which will be down at negative infinity, because I don't know where those are. They're infinite. But as long as I follow my end behavior, I can see that the graph at the right end does go up. So that'll probably be my absolute maximum. At the left end of the graph, it is going down. And so that's probably going to be my absolute minimum. So I think everything circled in blue or green, any place I have on the graph. So what's left is the stuff in red up there in the upper left. Those are my intervals. And I'm just going to take this opportunity as a reminder. Interval notation only refers to the x coordinate. So everything we've done on the graph so far has given us x coordinates and y coordinates, written in different ways with limit notation and coordinates, but it's given us x's and y's. Interval notation, just x's. Okay, so we just got to remember that. I find it most helpful to follow the number line. So it means I start from the left at negative infinity and work my way across that x-axis like a number line. So other people like to do the positive intervals because it's written on the page first. They do everything positive first, and then the negatives because it's written next on the page, and then the increasing and the decreasing. And if that works for you, that's great. Go for it. I am going to find intervals which start at negative infinity and work on my graph from the left side to the right. So there are two intervals that start at negative infinity, the negative interval and the increasing interval. So the negative interval starts at negative infinity and goes until -5. So it would be below the x-axis until I come across the graph to -5. And increasing is a longer interval. It starts at negative infinity, but continues increasing all the way until an x value of -2. Okay, so let's cover up part of the graph. I just want to see the part of the graph until -5. So we'll work on the negative interval first. Also, I will be increasing. So if I look at what information I do have, I've got an x-intercept, so I'm probably going to connect to that. The left end behavior is that the graph will be pointing down. I know at this point of the graph, I should be below the x-axis because it's negative and increasing. And I need to connect to the x-intercept. So the steepness that you draw this, whether it's straight or curvy, super steep, not steep, whatever, totally up to you. We have no information that describes like the slope or whether it's curved, or we don't know that. So artistic license. Once I get to that x-intercept at -5, the graph is no longer negative. I have completed that interval. I'm just going to cross it off just to help me keep track of what I've actually put on the graph. And at -5, we can see the graph switches into the positive interval. So from -5 until 1, I'm going to be positive, so above the x-axis. Okay, I'm not going to draw the whole positive thing yet. I just want to continue the increasing interval and note that I am now in the positive part of the graph. So I should be increasing until I get to an x value of -2. As I uncover this part of the graph, I can see, I've got some other stuff here I need to remember. There's a left-hand limit. So as I draw coming in from the left, I'm going to come into that left-hand limit, lift my pen, and then as I continue, I'm going to put my pen back down at the right-hand limit and keep going across the graph to the left. I need to be increasing this whole time and above the x-axis this whole time. The only way I can see doing that is, whoops, let's get that red. Okay, and then leaving from the right-hand limit, I'm going to go up and I'm going to hit that maximum point up there. So what I just drew is above the x-axis, it's positive, increasing the whole time. Even though there's that jump in the graph, when I made the jump from the open circle at the left-hand limit and the magic reappearance up there, it's not really magic, but the reappearance up there at the right-hand limit, that was an increase. And so I could have started a new interval, the increasing interval, the positive interval, both. I could have ended the interval at -3 and then started the new interval from -3 until -2. I didn't need to, but I could have. It might have been more clear if that's the way it had been written on there, with separate intervals to get from -5 to 3. And then since the graph stops, I could have stopped the interval and began another interval. It's not required because our little graph walker was positive this whole time, right? They like instantaneously reappeared up here, and it was positive everywhere. And also, as the graph walker walks from left to right, they're increasing that whole time. And then as they take that last step into what would be that open dot, they magically reappear instantly higher up. So that was an increase. Anyway, let's keep going. Goodbye, graph walker. So I've completed the increasing interval. Positive, I'm not done with that. I'm going to remain above the x-axis until I get to an x value of 1. I don't know if I'm actually going to be able to draw that whole thing right now, but I'll uncover the graph to an x value of 1. And then decreasing is the next interval. So from a maximum where I just stopped drawing, it makes sense that I would be decreasing afterwards because it was a maximum. I got to come back down. So decreasing from -2 until I get an x value of 1. Both of these intervals end at the same place. Positive interval and the decreasing interval both end at 1, and they both have round brackets in there. Oh yeah, I can see why. So at the x value of 1, I've got that two-sided limit, which is the open circle. That makes sense why both of the intervals would have a round bracket at this point. So when I continue drawing from the maximum, I need to come down. I'm going to hit that y-intercept and then connect to the two-sided limit. Or in this case, I'll just draw it backwards. There is this floating dot down at 1, -3, which we have labeled earlier. Okay, the dot's still there, but we're not going to connect to it because it's not the limit. So connecting from the other side of the two-sided limit, and I'm going to go off towards the right. So let's see what's going to happen next. Finish the positive interval. I finished the decreasing interval. I'm just going to keep track of what I've already done. So at an x value of 1, still decreasing, still positive. All right, let's see what we can do here. So positive for the whole rest of the graph is positive, but decreasing until an x value of 4. Let's see what's going on at 4. Oh, yeah, there's a minimum. Well, so this totally makes sense. I'm going to connect from the two-sided limit. I'm going to keep going down until I get to that minimum point. Oh, man. I'm not going to draw with the highlighter, though. If you want to make that kind of curvy, you totally can. You want to draw it as a straight line, whatever. We don't know which way it's supposed to go, so you choose. Once I get to the minimum point, my decreasing interval has finished. The positive interval stays until the end of the graph, so I'm never going to cross over to the bottom part of the x-axis. And I am now increasing. So starting at 4 with the square bracket, where that point, the minimum point is, I'm going to now increase and remain positive. And that matches what I've given myself as notes earlier. The right end behavior, the graph should be going up the right side. So I'm going to start from this minimum point and go up. So that gets me increasing, and that also matches the end behavior. And that is my graph. So I can double check. I can go back now that I have drawn my graph. I can go back through and verify that all of the intervals actually match what I've drawn. One of the things which is not so important on this graph because it only crosses the x-axis in one place. But a lot of times people lose track of the exact location when the graph switches from positive to negative because we stop paying attention to all the intervals and you're like, oh, it's increasing, it's decreasing, I think it'll connect to this dot and that dot, and we just start drawing stuff without paying attention to all the little details. So pay attention when the graph transitions from positive to negative where they have the same number. Shows up in both intervals. So the positive interval begins at -5 and the negative interval ends at -5. That tells us probably what's happening is the graph crosses the x-axis at -5. And in this case, we know for certain that happens because we're given the x-intercept. We're not always going to be provided with x-intercepts. We were this time, but in other graphs later on in the assignment, you're not always given the x-intercepts. And so we're going to have to pay attention to the negative and positive intervals where the same number shows up at the beginning of this interval and the end of that interval, and we'll know that's where it crossed the x-axis.